Okay, so we got a car towing a trailer. We've got the mass of the car and mass of the trailer, so we've got them separately. Car's moving upwards along the slope, angle alpha, sine alpha is sine over 25. We've got a resistance of 400 on the car and a resistance of 300 on the trailer. And the car's engine produces a constant forward force of 8,400 newtons. Okay, part A, calculate the acceleration of the car. And then, obviously I can simplify this diagram when I do my force diagram. So I got a car at front, and then it's towing a trailer. Okay, now the car is 1,500 kilograms, the trailer is 600 kilograms. The alpha, sine alpha is 7 over 25. Resistance of 400 on the car. So here's the car. So the resistance of 400 there, and 300 on the trailer. The car's engine produces a constant forward force of 8,400. So the car there has a force of 8,400. Right, those are all the what we call the external forces acting. Okay, we've got this tow bar here. Right, something must be happening on that tow bar. Right, when you've got a tow bar or tow rope, there's a tension in that. Okay, so with the tension we pull away from the particles. There's a tension there, pulling away from the car, but equally on the trailer it's the same tension, because it's connecting the car and the trailer. There must be a tension pulling on the trailer as well. They're equal and opposite, and this is moving up in acceleration A. So that's my force diagram. Okay, there's the force diagram. Right, I'll put the weights in yet. There's a 600 G acting down. There's a 1,500 G acting down there as well. So this diagram's getting a little bit messy now, right? There's normal reactions happening as well. Okay, because I want acceleration, I'm only really going to be dealing with parallel to the plane in this particular question. Okay, there are reactions. It's just going to be complicated. There's a reaction on the car there, and there's a reaction on the trailer there. Right, I need these weight components. So 600G there will be that one. That'll be 600G sine alpha, and the 1,500G. See, the diagram's getting rather messy, and I don't know where to put it. 1,500G sine alpha there. Okay, so when I apply Newton's second law, parallel to the plane, like going upwards, 8,400, I work my way down the diagram, 8,400 minus t, minus 400, minus 1,500G sine alpha, plus t, minus 300, minus 600G sine alpha, and that equals mass times acceleration. Now the mass is 1,500 under 600, so the mass is 2,100 A. So that's the force diagram. You see there the T minus T and the plus T cancel out. So on the calculations, 8,400 minus 400 minus 1500 times 9.8 sine alpha 7 over 25. Don't need to calculate the angle. Minus 300 minus 600 times 9.8 times 7 over 25 equals 2,108. So I'm just going to calculate that. 8400. So that's 1937.6, 2100A. So dividing that by 2100, that'll give me the acceleration. That's 0.9226, which is 0.92 meters per second squared. Okay, right, so it's part A, where I've considered the whole system and put all the forces on everything. Okay, now the second part of this question, okay, is asking me for the tension in the tow bar. Well, going back to my diagram, if I consider the whole diagram, I say the tensions are going to cancel out. So the only thing I can do, I either consider just the trailer or I consider just the car. And that way there'll still be a T in the diagram. Okay? Now then, because there's less forces on the trailer, only by one, I can just consider the trailer. Okay? So the second part, just consider the trailer. For the trailer, so basically I'm just looking at, there's a T going upwards, minus 300 minus 600 G sine alpha, and that's going to equal mass times acceleration. So 600 times, and the acceleration we calculated in the first part is 0.92. And then just take it over to the other side, 600 times 0.92, add the 300, add 600 times 9.8 times 7 over 25, and that tension comes to 2498.4 newtons. Is it asking for any degree of accuracy? No. Alright, so there's the answer there.